In this video, we're going to explore net present value and some other capital budgeting techniques and look at their investment rules, if you will. So why would we want to use net present value? So first of all, net present value is a measure of change in wealth for a company. So it identifies the benefits that stockholders would receive from doing a particular project. And unlike some other techniques, it uses cash flows, uses all cash flows. It identifies and uses the correct discount rate. That is, it identifies the riskiness of the project, the cost of financing that project, and incorporates it into the decision process. The other techniques that we have do not necessarily address all of these things. So the net present value rule is really just the total present value of future cash flows plus the initial investment. Now, of course, the initial investment is always going to be a negative number. We're going to estimate future cash flows, estimate the discount rate, and of course, we have to estimate the initial costs of a particular project. Now, the rule, the minimum acceptance criterion is you accept the project if the net present value is greater than 0. If you're ranking projects, you rank them by highest to lowest net present value. Now, I will tell you that if net present value equaled 0, even though it's not in the textbook, right? It's not typically incorporated in the most decision making, but most of the time they don't tell us what to do if it's equal to 0. Technically, it means nothing has changed. Doing a project doesn't take away value, doesn't add value, but in itself, doing projects that have values equal to 0, certainly it increases the asset base. Certainly it could increase competitive opportunities. So equal to 0 is not necessarily a bad thing. So if we look at a very simple process, what we want to think about here with this slide is what are the important components? We know that the cost is very important. We also know that the cash flows are important. We need to be as accurate as we possibly can with these numbers. The other important variable that we need to think about is the discount rate. Simply stated, the discount rate is the cost of financing the project. We have a concept of something called the weighted average cost of capital. And the weighted average cost of capital for a corporation measures the average cost of financing the assets of the company. So in a nutshell, the R here is very important. We need to understand the riskiness of the project. We need to understand what the cost is then of financing. Now, we have two projects that we're going to be looking at throughout this video. Projects A and B. You can see that B is twice as big as A. We have equal discount rates, though. So the discount rate and the reinvestment rate are the same. So these are equally risky projects. We just need to figure out whether or not we want to do these projects. So from the capital budgeting techniques worksheet, again, this is available, right? You enter the data, right? So you enter the data. Here's project A. Remember that the investment has to be negative, right? It's almost always going to be negative. We enter the discount rates up above. So here we have A and B. So the question here is, which project is better? Thinking about net present value. Net present value. The net present value of A is $34,000. The net present value of B is $93,000. So it is clear both projects are good projects. However, B is a superior project because it has a higher net present value. So as we go through, we will be looking and asking these questions, right? Project A has a lower net present value B. We would do them both if we could. But if they're mutually exclusive, if that means we can only pick one, that means we would pick project B. With respect to the internal rate of return, again, we look at this ratio. Is it greater, the internal rate of return rule, if this is greater than the discount rate, in this case 15%, you would want to do the project. And again, both projects are good with respect to the internal rate of return. However, the internal rate of return says the project A is better than project B. So we have a conflict. And we're going to be discussing this conflict throughout the next couple of videos. But the basic concept here is you should always choose the one with the highest net present value. But sometimes we get these conflicts that we need to try to explain. There is a tool called the net present value profile. Essentially what this net present value profile does, and again, there is a worksheet for this. You enter the data, right? So we have the discount rates. We also have a table that will calculate the net present value for each project, for each of these two projects, using a different discount rate. So we started off at 15% here and worked our way down. And you can see that as the discount rate increases, the value of the project itself decreases. The net present value decreases. So as discount rate goes up, value goes down. So this is what we sometimes refer to as the risk-return relationship. As risk goes up, returns go down. But what that means is that also as risk goes up, returns go down. That means also that value is going to be affected. This net present value profile then gives us graphically pictures of how these two assets react. You can see that in lower discount rates, right? In lower discount rates, project B is better than project A. But in higher discount rates, it switches and now A is better than B. This is an example, if you will, of the conflicts that we have when we think about capital budgeting, and in particular, the relationship between net present value and the internal rate of return. So again, we've been talking about this over and over again, right? Sometimes they give the same answer and sometimes they conflict. Net present value measures the change in wealth. Theoretically, it is always the correct answer. Seems like I'm repeating this several times as we go through the video, but it measures the change in wealth. It's the only one of these techniques that we discussed that actually measures the change in wealth. So that is the best of the tools that we have to measure capital budgeting and the process of determining what to buy. Another technique Sometimes it's actually referred to as an unsophisticated technique because it does not use the time value of money. But it says, how long does it take for the project to buy back the initial investment? How long does it take to recover your money? The minimum rule is set by management. So we're going to decide what number is acceptable to the company. That is very critical. If you think about, if you choose a number that's too big, then all kinds of assets will be acceptable. If you choose a number that's too small, then that's going to limit the expansion and growth of the company. So the payback period method is a very simple method, gives us a little bit of a picture about risk, right? But in general, it is a weak method for most corporations to use. As you see here with the payback method for project A is 2 years, and for B, it's 3.3 years. So again, if we have a 3-year benchmark, project A is acceptable with respect to payback. Project B is not acceptable with that. So again, we're looking at a technique. We need to understand what the technique's all about, but we do understand the decision rule that A is the only of these two projects we would do if all we used was payback. Now, the disadvantages of the payback period, as I mentioned, are many, right? It doesn't do time value money. It ignores cash flows after the payback period. It's biased against long-term projects, right? It benefits short-term projects more than long-term projects. And in the end, I think that the two things I think are most important is, number one is it requires an arbitrary acceptance criterion. There's no theory or technique that we can devise that will tell us what the best payback period is. And because of this arbitrary acceptance, it also doesn't have any connection to positive net present value. So accepting something based on payback period will not necessarily identify a project that has positive net present value. Now, what are the advantages? It's easy to understand. It's biased towards liquidity. More liquid projects will get their money back quicker than others. But it is sort of a risk measure. The greater the number, the longer it takes for you to get your money back, the more risky the project is. Now, a variation of the payback period is the discounted payback period. And in this case, all we do is take the time value of the cash flows and incorporate that into the technique. And again, you would accept the project if it pays back within a specified period of time. And the only thing that this frees up for us, again, if you think about the disadvantages, the only thing that it does for us is it gets rid of this time value of money issue. Everything else, all the other disadvantages are the same. So the discounted payback method still is a rather simple method, but at least it incorporates the time value of money. And in this case, you can see that the discounted payback for A is 2.7. For B, it's 4.0. So again, given our benchmarks of 3, and again, we might not want to have chosen 3. I mean, obviously, it has to be more than 3 because of the discounted. So maybe we could have chosen 4. But regardless, in this case, B is not acceptable and A is acceptable. So that's the end of this video. Look forward to talking to you more in the next video.